This is the process of simplifying the extra little bits, the harder bits. That's where we combine terms, but also get rid of any unnecessary powers and roots. So, as well as adding, subtracting, multiplying and dividing, we can deal with powers and square roots as part of simplifying, and that's what we're going to do in this video. A little bit of terminology. The bar of a square root tells you what's inside it. So in the first case here, only the 81 is squared, which is 9, the x squared is left unchanged. In the second case, the whole of it is square rooted, including the x squared. When we have powers, we put brackets to achieve the same thing. This too applies only to the y, this too applies to everything inside the brackets. And that's how we deal with brackets. Anything on the inside is multiplied out the appropriate number of times. So 6x squared is 6x times 6x, 36x squared. And that includes any powers on the inside. So this time it's a cube, so we multiply out the contents of the brackets 3 times itself. 2 times 2 times 2 is 8, and there are 6 x's. It's easier to do it that way than to learn a formal rule, even if that might be in a textbook or your notes. Just multiply it out. You're only going to have to do it once or twice anyway. Square roots are harder. With them, we take the square root of the number and halve the power. So 16 squared is 4, and half of 2 is 1. That's because 4x times 4x is 16x squared. That's what a square root is. One more. Square root of 9 is 3. Half of 6 is 3, because 3x cubed times itself is 9x to the power of 6. Now the hardest bit is algebraic fractions. They're just dealt with as ordinary fractions. If you follow the rules consistently, you'll get there. When we multiply the top line and the bottom line. When we divide, we flip the divisor so that k over 3 has become 3 over k, and we multiply it then through top line and bottom line. Adding is where it usually comes unstuck. To add the two fractions, you have to have the same denominator, and that denominator doesn't change. 2x squareds and 3x squareds give 5x squareds all over 4. That's how we add fractions as numbers, and that's how we do it also with algebra. If the top two items are not like terms, then they cannot be added. So the result is a fraction where the top two terms cannot be added. It stays all over 3 though, because the denominator doesn't change. If the denominators aren't the same, then they need to be made the same. I've multiplied here top and bottom by 5, because 35 over 20 is 7 over 4, and 3 over 5 is 12 over 20. I can add the like terms, 47x all over 20. And you can do that also if you have the bottom lines as algebraic terms. In this case, I've taken this number, 2 over x, multiplied it top and bottom by 3. So I now have a consistent bottom line. I can add 6 and 5 as 11 over 3x. Subtraction is the same as addition, except obviously we do a minus. We make the denominator the same. 2/5 is 4/10. I subtract the like terms on the top. I'm left with 1x over 10. So there we have it. Exponents, you multiply out the contents of the brackets the appropriate number of times. For square roots, you square root the number and halve the power. And for fractions, you can only add with the same denominator, and then the rules of algebra still apply for the actual adding.